Alright, so let's go ahead and finish up this video with some of these challenge problems. So I'll go on to another page for this. So this is going to be question 37. These ones are not going to be necessary, but again, they're just helpful to know if you want to know just a little bit more advanced applications, what you'll do a little bit more in Algebra 1 and Algebra 2, and so on and so forth. So going ahead and adding some of these, my pen is doing this again, more complex fractions, especially with variables here. So let's see, we're going to add these three fractions together. So we need common denominators, so I'm going to go straight into that. I think they all have x in common, so don't have to worry about that. It's a little bit messy. And so I think 3, 4, and 2 meet at 12 for the first time. So we'll do times 3 and times 3 to get to 12, times 4 and times 4 to get to 12, and then times 6 to get to 12. So if we were to go ahead and do that, 13 times 3 is going to be 39. And that's going to be 2 times 4 is going to be 8. Whoops. It's going to be 8, and then 6 times 6 is going to be 36. So all of those are going to be added together in the numerator, and on bottom they're all going to be over 12x because that's going to be the common denominator here. So taking a look at top, we have 39 plus 8, that's going to be what, 47? And then 47 plus the 36, that should equal 83. And so this whole thing should just equal 83 over 12x. That would be like the most simplified version of this fraction, okay? Again, if we knew what x was, we could just plug it into this, and it would be the same as doing it to all three parts and then adding them together, okay? So there's 37. That you can't simplify anymore just because 83 and 12 have nothing in common besides 1 for a GCF. All right, for 38, let's see, we have 14 over, still doing that strange thing, 14 over 4y. Again, I'm not sure why it's doing that. It's being a little finicky. Minus, yikes, what's going on here? All right, minus 4. It's really just drawn some random lines here. Minus 4 over 8y, and then plus, my goodness, plus 8 over 5y. Alright, so looking for a common denominator here. I think they all have a y, so when do 4, 8, and 5 meet for the first time? I think that's going to be 40. So I'm going to do times 10 times 10. Then I'm going to do times 5 times 5. And I'm going to do times 8 times 8. So 14 times 10 is going to be 140. Then minus 4 times 5 is going to be 20. And then plus 8 times 8 is going to be 64. And that whole thing is going to be over 40y. Okay, and so 140 minus 20 is going to be 120. 120 plus 64, I think that's going to be 184. So it's going to be 184 over 40y. I think using a GCF, maybe not a GCF, but I think a common factor I can use is at least 4, right, to begin. Divide these both by 4. 184 divided by 4, I think it's going to be 45 is 46. So I think this is going to be 46 over 10y. And yeah, I should have divided by 8 instead. 92, 46. No worries. Yep, I guess I didn't get the GCF. It's no worries though. Could have done 8, I didn't think of it. No worries. That's going to be 23 over 5y. And so this would be the simplest way of kind of writing that original fraction as one fraction instead of 3 different fractions. Okay, so just check real quick again. 40, 140, 20, 64, 120, 184, 184 technically divided by 8 would be 23 right away. Yeah, okay, cool. I think this is right. For 39 here, we're going to multiply these two scary looking things together. I promise they're not too bad though. So 39, we have 3x squared y over 8. We're going to multiply that by 20xy squared over 21. Okay, so looking to cross cancel some things here if possible. doesn't seem to have too much, but I do know this 3 and 21 both have 3, so that would become 1 and that would become 7. Again, those are the numbers or the coefficients or constants, however you want to think about them. And then this 8 and 20, you can divide them both by 4, and you would get 2, and then we would get 5 here. Okay? And so let's see what we have. If we multiply these numbers together, 1 times 5, that's going to be equal to 5. And then if we go ahead and multiply this x squared by x, that's just going to be x to the 3rd power. And then if we multiply this y by this y to the 2nd power, that would be y to the 3rd power. And then if we multiply whatever we have left on bottom here, so it's really just 2 times 7, that'll be 14. So that would be the most simplified version of this multiplication problem. Okay, so there we go for 39. And finally for 40, check that out. 40 says find the value of x so that this would be true. Okay, so we have 3.5 multiplied 3.5 multiplied by 1 over x plus 5 over 3x, get rid of all this nonsense, is equal to 1. And so we need to somehow solve this equation and find out a value of x. So how would we start here? Well, I think we would start by just going ahead and changing this to an improper. So 3 times 2 is 6 plus 1 is 7. I think I was already thinking about the 7. So that's going to be 7 over 2 times 1 over x plus 5 over 3x is equal to 1. And when we do order of operations, we'd have to multiply first. So we would just kind of look here and multiply these two values. So 7 times 1 would be 7. And then 2 times x would be 2x. And we're going to add that to 5 over 3x. And that would equal 1 somehow, right? Now, it's still kind of hard to see what value of x would make this true, but if we find an LCD, we can multiply this one by 3 and this one by 3, multiply this one by 2 and this one by 2. We would get 21 over 6x plus 10 over 6x is equal to 1. Now that they have common denominators, we could add them together and say this is 31 over 6x is equal to 1. Okay, and if we have, we're looking for this value of x that makes this true, and what's kind of neat about this is we could actually flip both sides of the equation. Neat little trick here that not many people use, but I like using. And you can take the fraction on the left and turn it upside down, as long as you take the other side of the equation, also flip that upside down. And if you flip 1 upside down or 1 over 1 over itself, it still is 1, so it doesn't matter. This way solving for x can be a little bit easier, and we can multiply by the reciprocal on both sides. So we can multiply the left side by 31 over 6, or it's called the multiplicative inverse. Either one is perfectly fine. If we do that, 31 and 31 cross cancel, and 6 and 6 cross cancel. That's supposed to happen if we multiply by the reciprocal. So we're just left with x is equal to 31 over 6. Okay. You could also say that x is equal to 5 and 1/6 if you want to say the mixed number version, right? But here, this would be the solution for this equation. Okay, so let's see what we've covered so far here. I think that wraps everything up. That's all 40 of these questions. So these were the first few problems where we had improper fractions to mixed. Then we simplified some fractions using the GCF. Then we added and subtracted using some LCDs. Then we multiplied, cross-canceling some common factors, looking for the GCF if possible. Then we went into dividing some fractions, where we talked about keep, change, flipping, and rewriting all division problems as a multiplication problem. Then doing some cross-canceling with some common factors as well. Then we talked about visually seeing what the multiplying and dividing kind of looks like. That's important to just kind of deepen your understanding of just not memorizing a process, but knowing visually what's actually happening. Did a couple word problems, Bruno with his chocolate chip cookies, and then Ola with the swimming pool, figuring out the width. And then we finished up with some challenge problems here. All right, so hopefully that was helpful. All right, good luck.